Hello, this is the video for section 7.6. It's similar transformations, and what we're looking at is that a dilation is a similar transformation. So we're going to start by folding this over like this, and it says determine whether the dilation from x to y is an enlargement or a reduction. When it gets larger, then it's an enlargement, and when it's smaller, then it's a reduction. And then find the scale factor. So we're just looking at the picture from here to here because it says from x to y. Is it enlargement or reduction? And it is an enlargement. It's getting bigger. And then it wants a scale factor. Please make sure that you write scale factor when you're giving me your answer so I know that that's what you're trying to indicate. All right. This does tell us it is a dilation, and a dilation is a similar transformation. So we know that we could compare just one side. We get really lucky when it's on a horizontal or a vertical. This is 1, 2, 3. And this is 1, 2, 3, 4, 5. And these are the parts that correspond. This one's a little bit different than what we have done, because it really does matter whether the picture is getting bigger or whether the picture is getting smaller. Because it's an enlargement, its scale factor is actually 5/3. That's not what we've been doing, but to make it bigger, it has to be bigger than 1. So this is the actual answer. So in this section, it matters whether it's being an enlargement or a reduction. All right, so let's take a look inside, and we're doing the top one. And from here to here, remember, we're going from x to y. Is it an enlargement or a reduction? This one is a reduction. Now we're looking at the scale factor. It really doesn't matter if you do the horizontal or the vertical on the x, as long as you do the corresponding side for the other figure. I am going to do this side right here. 1, 2, 3, 4. And this one would correspond with the smallest side, so it would be this one over here. So what we've been doing is writing 4 divided by 2, because the signs haven't mattered what they're telling you. But making it a reduction means that this fraction has to be less than 1. It's still the comparison of those two things, but if you were to multiply this fraction, that's what it would be. Oh, and I'm sorry, I forgot to mention, make sure that you always simplify your fractions. So that is the answer that I would be looking for. If you multiply by 1/2, it would make the picture smaller. All right, this one from here to here, I really can't tell if it's a reduction or an enlargement. So I'm going to count 1, 2, 3. And the corresponding side would be maybe up here. 1, 2, 3. So this one's really not a reduction because it didn't get smaller, and not an enlargement. It is still technically a dilation, and if we do the scale factor, it's 1 to 1 because it happens to be 3 divided by 3, which reduces to 1 to 1. All right, this would be worth bonus points because this is the only time you're going to see this word. It's an isometry. All right, on the next one. From x to y, this would be an enlargement. Luckily, we got that horizontal that we can correspond with. 1, 2, 3, 4 on the x. And then 1, 2, 3, 4, 5, 6, 7, 8 on the y. That reduces to 1/2. But then if you multiply by 1/2, it reduces it. So we have to make sure that our answer is 2/1. Because that would make it larger. That would make it twice as large. Okay, so from X to Y. So don't forget, even though how the picture is made, you're still going from X to Y. So this looks like a reduction. And I'm going to do 1, 2, 3, 4, 5, 6. Compared to the 1, 2, 3, 4. And that reduces to 3/2. But if you multiply this, it's bigger than 1. This fraction is bigger than 1. If you're not able to tell, just put it in your calculator. 3 divided by 2 is 1.5. And so I need to flip that fraction. And that's why we don't write an equal sign. We're saying that it implies. That's the next thing that we need to do. So simplify and make sure that it's larger than 1 if it's an enlargement. Larger than 1 if it's an enlargement. Okay, then next section we got going down here. Are they similar? So here we actually don't know if they're a dilation, but we're trying to prove that they are. Plot the given points and determine whether the figures are similar by using side, side, side. So remember, that's all the sides are proportional. Side, angle, side, or angle, angle, similarity. So they're all supposed to have that little wiggly sign to make sure that you're saying that they're similar, not congruent. And I'm sorry, I made a mistake here. This is D, E, F for these points. Sorry about that. And so let's plot them. A is -4. 1, 2, 3, 4. -4 on the x-axis, and then up 3 on the y. 1, 2, 3. Label it A for me, please. Then -4. -2, that would be down 2 on the y-axis. And that's B. And then a +1 and -2, 1, 2, would be the C. And we will connect it. All right, and then we have D, E, F. D is at the -2, up 4, 1, 2, 3, 4. E is 3, +3, 1, 2, 3, up 4. And then F is at the +3 on the x-axis and down 1 on the y-axis. Connect the points. Okay. Good news! When you have the horizontal and a vertical line, these are 90 degrees, so they already gave us an angle. Whoop, whoop. So we know that angle B is congruent to angle E. So now we just need to find a scale factor. I'm going to do 1, 2, 3, 4, 5 because that's easier than doing the distance formula. But I will remind you what the distance formula looks like. And 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like this is not a dilation, but this is maybe a reflection. And just reflected that off of this line right here. Okay, it could also be a translation where they rotate one of the points so it goes all the way down here to F. So it could be a lot of things, but they are congruent. How do I know? Well, 5 divided by 5 is 1. And I'm supposed to know, is that equal to the other scale factor, 5 divided by 5? And it's still 1. Sorry, let me write that again. It is still 1. And that's how we know that the two sides are proportional. Making these two triangles similar by side, angle, side. Similarity. Okay, let's take a look inside. So let's plot the points first. 0, 4. So 0 and then 4. 1, 2, 3, 4. And that's A. Negative 4. 1, 2, 3, 4. 4. That's B. Negative 4, negative 3. 1, 2, 3. Okay, when they give us a right triangle, that's great. A horizontal and a vertical means that this angle right here will be 90 degrees. Okay, and we got 0, 1 is the D. E is 3, 1, 2, 3, 1. Oh, sorry, I messed up on the D. No. Yes, I did. 0, 1 is 0 on the X and then up 1. That's D. This is E. And then 0, negative 4. 1, 2, 3, 4 is the F. Okay, so that's 90 degrees. We have an angle. Woohoo! Now we know that angle B is congruent to angle D. Now we just got to verify those sides. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5. I'm just recounting. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4. 1, 2, 3. Okay. So since this is the longer side, I'm going to compare to this one. So I'm going to do 7 divided by 5. And I want to know, is that equal to 4 divided by 3? And I don't have my calculator with me, but they're not. So you're just going to put it in calculator to see if those decimals are the same. And they're not. So we can't say that these are similar. We say they're not similar. We can't say by what. It can't be side angle side because they're not similar. That means this was not a congruent transformation. Alrighty, let's take a look at these. We're going to go ahead and plot the points. Negative 5. Negative 1. That's A. Negative 2. 4. And then 1, negative 1, that's a C. And if you'll please label it for me. If you got a straight edge, that's great. You can pause the video and get one if you would like. They're in the front of the room. Then the other one is negative 1, negative 4. 1, 2, 3, 4. That's D. 2, 1, 2, and a positive 1. E. 1, 2, 3, 4, 5, and negative 4 for the F. Okay, so we can get this distance right here. We don't know how to get angles right now, but we can see if they're congruent or not. So there's several ways that we can do this. What I want to remind you of is that if one of the sides does not line up on the horizontal and the vertical, you have to do the distance formula. And the distance formula was the square root of, and then we're going to do the x's first, x2 minus x1 squared plus, remember that thing? Open parentheses, y2 minus y1, and then we have to square it. So you do have to do the distance formula if you can't find another way. But what you're trying to do is find another way to prove that these two triangles are congruent. We're going to do it, or similar. We're going to do it this way. 1, 2, 3, 4, 5, 6. 6. And remember that thing that said that if they were similar, then they would have similar parts. We're going to do this one. This one was, remember, called the altitude. That helps a lot because it really is the altitude. It lines up great. It's on a vertical line, so there would be 1, 2, 3, 4, 5. So if they are similar, so are their parts. They have similar parts as well. 1, 2, 3, 4, 5, 6. And then here's its altitude. So if you can't spot that, you might have to do the distance formula, still proving the same thing. And this is 1, 2, 3, 4, 5. So let's take a look at corresponding parts. We have 6 that corresponds with this one over here, 6. And is that equal to the altitudes, 5 divided by 5? Well, the answer is yes. They both reduce to 1. That is equal to 1. That means that this is similar. We didn't actually use any of the rules that we have, like side proportionality, but this is technically side similarity, because we proved that corresponding parts are similar. Alright, then the next one, -5, 1, 2, 3, 4, 5. Oops, -5, 1. Since these two were congruent, you could actually done a lot of things, but what I showed you was good. Make sure that you do the distance formula if you don't have that information. -2, 1. Sorry, that's the A. That's the B on this one. C is -2, -1.5. So -1 and then 0.5 is the C. And then for the D, -2, +4, 1, 2, 3, 4. That's the D. E is 4, 4. 1, 2, 3, 4. 1, 2, 4. F was 4, -1. Okay, like I mentioned, man, you really want them to land in the horizontal and the vertical. When they do that, we know that the angles are 90. That means that the angle B is congruent to angle E. And then we want to count 1, 2, 3. 1, 2.5. Here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So I would just like to compare the biggest side with the biggest side. So 3 divided by 6. And I need to know, is it equal to? You don't just trust it. You got to figure it out. If 2.5 divided by 5 are equal. Well, yes, they end up being a half. A half and a half. So, yay. They are equal to each other. That means that this was similar by side. Angle side similarity. Let's take a look at your homework. Okay, determine whether the dilation from A to B is an enlargement or a reduction. Is it getting bigger or smaller? The scale factor in this one, remember, it matters. If it's an enlargement, it's greater than 1. So if you're not really sure what the answer is, make sure you put that fraction in the calculator and see if it's greater than 1. And if it's a reduction, it has to be less than 1 for it to be the correct scale factor, because it does matter on the dilations. Graph the original figure and its dilation. What this notation means prime, so like it's the transformation. We call it A prime, B prime, C prime, and it's just what the original point changed to. Then verify that the dilation is a similar transformation. So you're doing the same thing we did before. We have to verify either by side, similarity. So if you don't have one of those sides, you have to do the distance formula. Angle side, angle similarity, we don't know how to do this really because they would have to give you specific angles. But let me give you an idea. If you have an isosceles, you do have two angles that are congruent to each other. Think about it. The other one that we have is side angle side similarity, and that's the one we've been doing when they give us a right angle usually, and then we have to prove that the other two sides are proportional.